All right, let's take a look at our vectors formula sheet. And there is a formula on there that we've never spoken about, the vector cross product, and that's what we're looking at. So let's just zoom in on that, and we're going to be zooming in on the second formula. We're going to ignore this for a second. Now, before I tell you what the vector cross product is and what it does, we're just going to do one. We're just going to calculate one so we know that we can calculate it. Now, important to note, the vector cross product uses our multiply sign, but it's not multiplication. It is something totally different. It's just that we use the same symbol for two different things. If they're vectors, we're not multiplying them. You can't multiply vectors. We're finding the cross product of them. That's a different thing. All right, so here's a question. Let's do the question. Determine U cross product V. All right, let me just write something down. All right, U cross product V. Now look at our formula. It deals with the vectors in column notation. So I'm going to do the same thing. I'm not going to try to overcomplicate this. So U is 2 minus 2, 1. And cross product, and V is 1, 1, 2. All right, now the cross product can be a little bit fiddly, so you've really got to take your time with it and make sure that you understand what the formula does exactly. All right, let's take a look at what we need to do. A2 times B3. All right, this is A and this is B. So A2 is this thing here and B3 is this thing here. So my first step is to do negative 2 times 2. And then the formula says I should subtract A3 times B2. A3 times B2. All right, and that's basically it. We just keep following through this formula. All right, to come up with this next one here, we're doing A3 times B1, A3 times B1, so 1 times 1, minus A1 times B3, A1 times B3. Okay, and finally to come up with the third one, we're doing A1 times B2, A1 times B2, so 2 times 1, and minus A2 times B1, negative 2 times 1. Okay, done. And then you just calculate that. You don't need to watch me do that. So we've done it. The cross product of U and V is negative 5, negative 3, 4. We've solved this question. We've answered it. Now the question must be, what is that? What have we done? We've got two vectors. We've found the cross product. What is it? All right, let me just erase all of this, but we'll keep our answer and then we'll talk about it. All right, we're in 3 dimensions. All right, this is vector U, the one that we were just calculating with, and this green one is vector V, the one that we were just working with as well, and we're in 3-dimensional space. Okay, now, what does vector U cross product V look like? Let's take a look. Here, bang. This blue one here is U cross product V. Now, if we take a look at them, you might come up with a bit of a conjecture here. And in fact, I can show you, bang, bang. This new blue vector is at right angles to vector V, and it's at right angles to vector U as well. So the cross product has this amazing thing going on where if you find the cross product of two vectors, U and vector V, then the cross product of them, we're going to end up with one that's at right angles to them. Let me just draw a picture of that. Ta-da! So this is one of the major properties of a cross product. If we take the cross product of U and V, we're going to end up with a vector that is perpendicular or normal. We're going to use that word a lot. That is normal to vectors U and V. Let's write it in words. The cross product of U and V is perpendicular to U and V. And I really need to insert the word normal here because I really need you to know it. Is normal at right angles to U and V. Okay, that's the cross product of U and V. What if we did the cross product of V and U? Okay, we're going to jump through that one way faster, but there is an important thing that we need to learn from this. So I'm just going to get rid of some of this and talk about the cross product of V and U. So second example, we're not doing U times V, we're doing V times U, cross product. All right, you don't need to watch me do it. I'm just going to write my working out real quick. All right, so I did my working. I followed the formula. I don't have this memorized. 5, 3, negative 4. And you can see this answer is different to that answer. They're obviously related to each other, but they are different, right? So order matters when it comes to the cross product, right? U cross product V is not the same as V cross product U. But let's take a look at the picture of that and see what it actually looks like. Just a note, the question was given in I, J, and K components, so really I should probably give my answer when I'm finished working on it in column notation in I, J, and K components as well. Probably should have done it for this one as well. Okay, where was I? Let's take a look at the picture of this. All right, so this is V times U, right? This is U times V. Now, this blue one here, this was U times V. Right, this is U and this is V. Let's look at where V times U is. And I'm saying times cross product. All right, there it is. Hopefully you can see it. There it is. It's hiding down there. It's right here, right? And you can see these are lined up. And most importantly, we've got this right angle thing happening again. Okay, so they're not equal to each other, but they both create these perpendicular vectors, right? They're both normal to U and V. We can talk a little bit about how to predict which direction it's going to go in. These are our two vectors, U and V. This is U cross product V, and this is going to be V cross product U. And again, there's right angles in there, right? There's a right angle there, and there's a right angle there. It's getting a little bit messy. How do you deal with this? All right, so if you've ever used a screwdriver, and I know that seems ridiculous, but if you've ever used a screwdriver, you will instantly be able to figure out how this works, right? If you want to screw this screw into the ground, if you want it to go down, you need to rotate it this way, lefty-loosey, righty-tighty. Right, look at what's going on here. When we did V times U, right? When we screwed it this way, we screwed it down, right? So if you can see vector V and U in your mind, you can see where vector V cross product U will be because of this, right? Now, if you want it to go up, you need to screw it this way. And so in our picture, you can see that when we screwed it this way, right? It went up. So there is a logic to whether it's going to go up or down. Not that up or down means much in this sense, but comparing them to vector U and vector V, if you are cross-producting from this one to this one, then it's going to shoot upwards. If you're cross-producting from V to U, then it's going to shoot downwards. All right, so that's everything I wanted to talk about the properties of cross product in this video, but there are more things we need to know about the cross product. Before we finish off, I need to show you like the actual question you're going to get asked, because you're not going to get asked a question like this. You're not going to get asked a question like this. This is the sort of question you would actually be asked. So this is the kind of question you'd actually be asked. Now, they're the same question. It's just that one of them I wrote the word normal and one of them I wrote the word perpendicular. Same deal. If we jump into these really quickly, importantly, you can choose to do A cross product B here, or you can choose to do B cross product A here, because it doesn't matter what order we go in. We're still going to find, if this is vector A and this is vector B, if we do this, if we do B times A, B cross product A, we'll get this. If we do A cross product B, we'll get this. Both of those answers will be correct. But by convention, let's do the first one, cross product the second one. Now I've written it out, and you'll notice that the B vector here doesn't have a K value. It doesn't matter, it does have a K value, 0K. So we put that in. We could even end up with one that was just like 3J, in which case you've got a 0I and a 0K. All right, once you've done that, you just follow these rules right here very carefully, because it's very easy to make mistakes here. That's it. 2, 1, negative 7. You could finish with a sentence something like, a vector that is perpendicular to the stated vectors is 2i plus 1j or j minus 7k. All right, that is an introduction to the vector product. We haven't covered like some of the coolest things that it can do, and also keep in mind that the vector product is used in some future stuff, right? So it's not like, hey, we've learned this one thing and we're not going to do anything with it. We're actually going to do quite a bit with it. This is just the beginning. Here's how you calculate it and what it does. Done.